Before you even poured your coffee this morning, an artificial intelligence likely altered your morning routine. And, you probably didn't even notice.
Yeah, that happens constantly. People don't realize it.
Right. We usually picture AI as this, some distant, world-altering force, maybe an impenetrable wall of code in a Silicon Valley basement. But the reality is much quieter, much more invisible, and honestly, a lot more powerful. You are already interacting with it multiple times a day.
That is the exact disconnect we constantly run into. We are so conditioned to look for the massive, sweeping disruptions, the sci-fi movie
Oh,
stuff.
totally. The Terminator robots and all that.
Exactly, which means we become completely blind to the subtle, structural ways this technology has already woven itself into the fabric of our daily lives.
And that is the exact premise of our deep dive today. We are pulling from the SkillUp Guide to AI in Everyday Life.
It's a great source for this kind of grounding.
It really is. Our mission isn't to rehash the tired debate about whether AI is going to take over the world. You already know AI exists. You probably already use it. Today, we are going to look under the hood.
Right, getting into the actual mechanics.
Yeah, we want to dissect the actual mechanisms behind the tools you take for granted. How this technology practically operates when you search, learn, navigate, and solve problems.
The guide makes a really compelling case that AI is no longer a tool you have to deliberately seek out. It's the invisible infrastructure supporting the apps and services you already rely on.
Okay, let's unpack this. Because to really understand that infrastructure, we have to strip away the lingering sci-fi baggage about what AI actually is at a functional level.
Which is surprisingly mundane when you get down to it.
Exactly. The SkillUp Guide defines it as technology that helps machines learn from information, recognize patterns, and make useful decisions. They emphasize heavily that it's a data processing system, not a digitized human brain.
Yes, that distinction is crucial. It's not alive.
Right. But let's ground this in a real-world scenario. Think about human pattern recognition. Say you have a coworker, and you're trying to predict their morning coffee order.
Okay, I'm tracking.
Over a few months, you notice that if the temperature drops below 50 degrees and it's a Tuesday, they always show up with a hot vanilla latte.
Very specific, but yeah.
But, if it's a Friday and sunny, it's an iced coffee. Your brain is passively weighting different variables, weather, day of the week, temperature, to predict an outcome.
Right, you're essentially constructing a mental model based on historical data.
Yeah. But it takes me months of observation to build a relatively simple model for one single person. AI is essentially doing that same weighting of variables, except it processes the coffee habits of a million people instantaneously.
And it doesn't forget any of it. What's fascinating here is that the real power comes from continuous data processing.
But here's where I want to push back a little.
Sure, go for it.
Calling that process learning feels like a massive stretch to me. A complex calculator doing multivariate math isn't learning in any meaningful sense of the word.
I hear what you're saying.
If the guide is explicit that this is not a human brain, why do we give an AI the credit of learning just because it updates a massive spreadsheet?
It really comes down to autonomy. Think about a calculator. A calculator only does exactly what you tell it to do.
Right, I punch in the numbers, I get the result.
Exactly. And if you input the wrong formula, it will spit out the wrong answer forever until a human physically intervenes to fix the formula.
Okay, fair point.
When the SkillUp Guide talks about a machine learning from data, it's referring to the system's ability to adjust its own internal math without human intervention. We aren't talking about biological learning, where chemical synapses fire in a brain. We're talking about mathematical optimization.
Wait, so the system is actually rewriting its own code?
Well, no, not rewriting the foundational code,
What?
but it's constantly adjusting the weights and probabilities within its model.
Oh, I see.
Let's stick with your coffee analogy for a second. If the AI model predicts your coworker wants an iced coffee because it's sunny, but the coworker actually orders a hot tea, the system registers a mathematical error.
It knows it got it wrong.
Right. It compares its prediction against reality. Then, through a process called backpropagation, it goes back through its own internal network and slightly adjusts the weight it gave to the sunny weather variable.
Interesting.
It essentially tells itself, okay, sun is a less reliable predictor for this specific user than I previously calculated.
Wow. So it's just this continuous feedback loop.
Relentless is probably a better word for it. The real utility of AI doesn't come from it being smart in the human sense. It comes from the fact that it never gets fatigued by data processing.
It does need a coffee break.
Exactly. Every single interaction, every correct prediction, and every incorrect prediction is fed back into the model. It uses the error gradient to make the math for the next prediction microscopically more accurate.
So if we take that mechanism, that relentless autonomous error correction, and apply it to us, things get deeply personal very quickly.
Oh, absolutely.
Because if the fight is constantly correcting its own errors, it can also map out and correct our errors.
Which fundamentally changes how we interact with information. I mean, the underlying math is the same, but the output shifts from predicting a behavior to optimizing human performance.
Here's where it gets really interesting, because the SkillUp Guide uses this phenomenal example of language learning apps.
That's a great example to look at.
We all know what traditional education looks like. You sit in the classroom, the teacher has a curriculum, and 30 students move through the material at the exact same pace. It is the literal definition of a one-size-fits-all model.
And that model is, frankly, structurally inefficient.
Totally.
If you instantly grasp verb conjugations but you constantly stumble over vocabulary, the traditional system still forces you to sit through the conjugation lectures.
It's agonizing. You're wasting time on what you already know, and you aren't getting enough reps on what you're actually failing at.
Right.
But the guide illustrates how AI shatters that model. An AI-powered language app doesn't have a static curriculum. It uses that same pattern recognition we just discussed, but it turns the lens on your cognitive performance.
It treats your mistakes as the data points.
Exactly.
Yeah.
It uses your mistakes to build its model.
It builds a probabilistic map of your memory.
Okay, you're going to have to elaborate on
Okay,
that because that sounds intense. What does mapping my memory actually look like under the hood?
Okay, so when you use a modern AI language app, it isn't just grading your answers as pass or fail, it's logging a massive amount of metadata.
Like what kind of metadata?
Well, let's say you misconjugate a specific past tense verb. The AI logs the error, but it also calculates the mathematical weight of that error against your historical performance. It's using what's essentially a spaced repetition algorithm on steroids.
Okay, spaced repetition, yeah.
Based on the millions of other users who have made that exact same error, the AI calculates the precise moment your brain is most likely to completely forget the correct answer.
No way.
Yeah, and it serves that specific verb back to you right before that decay happens.
Okay, but how does the AI distinguish between a genuine cognitive gap and just a simple mistake?
What do you mean?
Like, what if I actually know the verb perfectly well, but I was, I don't know, walking to the subway, bumped into someone, and fat-fingered the wrong letter on my phone screen? Does the AI suddenly think I'm failing Spanish because of a typo?
That is exactly where the scale of the data becomes critical. A rudimentary system might penalize you for the typo, but a sophisticated AI looks at the entire cluster of data.
So it looks past just the wrong letter.
Right, it analyzes your time to answer. Did you answer in 1.2 seconds, which aligns with your usual speed for concepts you've mastered but just hit the wrong vowel?
Oh, I see where you're going with this.
Or did you hesitate for 6 seconds before submitting the wrong answer? It compares your current interaction against your baseline velocity.
Wait, so the hesitation itself is a data point.
A massive one. The AI is synthesizing all of those microinteractions to differentiate between a physical slip and a real conceptual misunderstanding.
That is wild.
And once it identifies a true conceptual gap, it dynamically restructures your future lessons. It pulls that tricky concept forward, weaving it into different contexts, maybe testing you on it via audio next time instead of text until the error rate drops.
It proves a larger point that the guide drives home, which is that knowledge transfer is infinitely more efficient when the friction of a generalized curriculum is removed.
It really is.
The AI basically acts like a hyper-personalized tutor that never loses patience, never judges you for making the same mistake 5 times, and just adjusts the syllabus in real time based on your cognitive load.
It completely flips the educational paradigm. The human is no longer expected to adapt to the pace of the tool. The tool is mathematically forced to adapt to the pace of the human.
That real-time adaptation is incredible for learning. But that exact same underlying machinery taking in messy data, filtering it, and predicting the optimal path forward doesn't stop when you close the language app.
Not at all.
That same probabilistic mapping applies when we physically move through the real world.
Oh, definitely. The navigation example in the source material is arguably the most perfect illustration of AI operating as invisible infrastructure.
Let's dig into that, specifically looking at Google Maps or similar navigation tools.
Yeah, let's do it.
Now, as an informed user, you probably already know that your GPS app uses AI. You plug in an address, the screen populates a route, and maybe a little bubble pops up saying, "We found a faster route, saving you 6 minutes."
Right, and we just tap it and go.
You tap accept, you keep driving. But the sheer volume of real-time data processing required to make that little bubble pop up is just staggering.
It is a monumental feat of data synthesis. The app isn't just looking at a static map. It is constantly ingesting a live stream of telemetry from millions of individual smartphones moving along the road network.
Which brings up a massive logistical problem. Real-world data is incredibly messy.
Very messy.
If the AI is relying on the speed of smartphones to determine traffic, what happens when the data conflicts? Say you and I are on the exact same stretch of highway. I'm driving 70 miles an hour, but you pulled over onto the shoulder to take a phone call.
So my speed is 0.
Right, so your speed is 0. How does the AI know the highway isn't blocked? Why doesn't it instantly reroute thousands of cars behind us because your phone is sitting still?
Because it's applying advanced noise filtering. This goes back to why AI is so much more than a simple calculator. It has to contextualize anomalies.
Okay, how does it do that?
Well, if one phone is stationary on the shoulder, but the 20 phones passing through that exact same GPS coordinate are moving at 70 miles an hour, the AI mathematically isolates the stationary phone as an outlier.
Oh, I get it.
It assigns a very low probability to a traffic jam and a very high probability to a parked car.
So it basically suppresses the irrelevant data.
Sorry, to put it more accurately, it downweights the anomaly.
Gotcha.
But let's say 3 phones suddenly drop from 70 miles an hour to 0 in the middle lane, and the phones approaching a mile behind them begin rapidly decelerating.
That's a different story.
Very different. The AI recognizes that specific cluster of telemetry as a high probability event, an accident, or a sudden bottleneck.
And it does this before the first driver even has a chance to report the accident.
Long before. And this is where the predictive modeling kicks in. The AI doesn't just look at the cars currently stuck.
What else is it looking at?
It compares this sudden bottleneck against historical models for this specific stretch of road at this specific time of day. It calculates the ripple effect, like how fast the backup is going to grow minute by minute, and then it looks at the secondary surface streets.
So what does this all mean for the user? The AI basically has to calculate if the side streets can actually handle the overflow.
That's the critical step. Because if the AI reroutes 3,000 cars onto a quiet suburban street, it just creates a new traffic jam.
Right, which defeats the whole purpose.
Exactly. So the algorithm calculates the optimal distribution of vehicles. It might only offer that 6 minutes faster reroute to a specific percentage of approaching drivers, intentionally balancing the load across the entire city grid in real time.
That's brilliant. And from the driver's perspective, literally none of that massive mathematical balancing act is visible.
No, you just see a blue line on a screen.
Yeah, you don't see the millions of data vectors, the outlier suppression, or the predictive load balancing.
If we connect this to the bigger picture, that invisibility is the ultimate metric of success for this technology.
How so?
Well, the most sophisticated AI isn't the one that requires you to write complex prompts in a sterile interface. It's the AI that seamlessly reduces the friction of your daily existence without demanding your attention.
Like you don't need to understand the algorithm to avoid the traffic jam.
Exactly. It just works.
Which perfectly encapsulates the core thesis of the SkillUp Guide. AI isn't some futuristic event waiting to happen. It is a utility. It's already here, operating in the background, like electricity.
That's a great comparison.
Yeah, I mean, you don't need to be an electrical engineer to benefit from a light switch, and you don't need to be a programmer to leverage artificial intelligence.
But understanding the mechanism, knowing that it's a system designed to continuously ingest data, correct its own errors, and adapt to the user, moves you from being a passive consumer to an active, informed user.
It demystifies the tool. Once you realize it's just relentless math optimizing for efficiency, the intimidation factor completely evaporates.
It really does. It becomes much more approachable.
You can look at a personalized learning app or a navigation reroute and actually understand the staggering complexity happening in the milliseconds before your screen refreshes.
And that understanding allows you to deploy these tools much more intentionally in your own life.
It gives you the context to see the machinery hidden in plain sight. Which brings me to a final thought for you to chew on as you go about your day.
Let's hear it.
We've talked about how AI is already mapping human memory to optimize learning, and how it's balancing the live telemetry of millions of cars to clear our roads. If this level of hyper-complex, invisible infrastructure is already operating seamlessly in the background of our lives right now, what other minor daily frustrations might quietly disappear tomorrow without us even realizing it was AI doing the heavy lifting?
Oh, that's a great question. It makes you look at every bottleneck in your day a little differently.
It really does. Thank you for joining us on this deep dive. We love pulling apart the mechanisms behind the tools shaping our world. Until next time, keep looking past the surface and take care.